Miss Amy's Math.
So we've already talked about consecutive integers. In today's lesson, we're going to learn about consecutive even integers and consecutive odd integers. Consecutive even integers are the even integers that follow each other in order, like 2, 4, 6, 8, 26, 28, 30, -6, -4, -2, 0. And consecutive odd integers are the odd integers that follow each other in order, like 1, 3, 5, 7, -15, -13, -11, -9, and so on. When we see the phrases consecutive even integers and consecutive odd integers in word problems, we'll need to translate them into math. So for consecutive even integers, we'll let n be the smallest even integer, and then n plus 2 will be the next one, n plus 4 the next, n plus 6 the next, and so on. And for consecutive odd integers, while it may seem counterintuitive, it's the same as even integers. We'll let n be the smallest odd integer, and then the next odd integer is n plus 2, then n plus 4, n plus 6, and so on. Suppose that n equals 1. Then we get 1 plus 2 is 3, 1 plus 4 is 5, and 1 plus 6 is 7. It works out because odd integers are all 2 units apart. For example 1, we want to find 3 consecutive odd integers such that the sum is 33. So when we see the phrase 3 consecutive odd integers, we know that we'll be using n plus 2, and n plus 4. We're told that the sum is 33, so that means we're going to add them up, and they'll equal 33. So we have our equation. Now we just need to solve for n. So we'll simplify the left-hand side of the equation, and we get 3n plus 6 equals 33. Then we'll subtract 6 from both sides, and we get 3n equals 27. Next, we divide both sides by 3, and we end up with n is equal to 9. So if n is 9, then n plus 2 is 11, and n plus 4 is 13. So 9, 11, and 13 are our 3 consecutive odd integers. For example 2, we want to find 3 consecutive even integers such that the sum of the first and 3 times the third is 100. When we see the phrase 3 consecutive even integers, we know that we'll be using n plus 2, and n plus 4. When we see the word sum, that tells me we'll be adding. It says the sum of the first, that's n, and 3 times the third. So that's 3 times n plus 4. It says that the sum is 100. So we have our equation. N plus 3 times n plus 4 equals 100. Now we need to solve for n. So we'll start by simplifying the left-hand side of the equation. We'll distribute the 3, and we get n plus 3n plus 12 equals 100. Now we collect like terms, and we get 4n plus 12 equals 100. Then we subtract 12 from both sides of the equation, and we get 4n equals 88. Now we divide both sides by 4, and we get n is equal to 22. So our 3 consecutive even integers are 22, 24, and 26. For example 3, We want to find the greatest of 4 consecutive odd integers, such that the sum of the second and twice the fourth is negative 25. So we see the phrase 4 consecutive odd integers. That means we'll be using n plus 2, n plus 4, and n plus 6. Next, we see the word sum, so that tells us that we'll be adding. It says the sum of the second, that's n plus 2, and twice the fourth, so that's 2 times n plus 6. It says that the sum is negative 25, so we have our equation. N plus 2 plus 2 times n plus 6 equals negative 25. Now we need to solve for n, so we'll start by simplifying the left-hand side of the equation. We'll distribute the 2, and we have n plus 2 plus 2n plus 12 equals negative 25. Then we'll collect like terms and add the constants. So we get 3n plus 14 equals negative 25. Now we subtract 14 from both sides of the equation, and we have 3n equals negative 39. Next, we'll divide both sides by 3, and we have n is equal to negative 13. Now our goal was to find the greatest of the 4 consecutive odd integers. So the greatest is n plus 6. So we have negative 13 plus 6 is equal to negative 7. So that's it for this lesson. If it helped you at all, please give it a like or let me know in the comments.